Hey guys, it's Off by One here, and today we're going to be solving word break. In this problem, we're given a string s and a dictionary of strings called word dict, and the problem wants us to return true if s can be split up into the dictionary words. So for example, here we have the string Leetcode, and we have the word dict with the words leet and code in them, and obviously these two words make up this string, so we would return true. So I'm going to show you the brute force solution first, and then we're going to work our way up to the best solution. So let's see, what is our brute force solution? Well, we know we want to iterate through the whole string at one point because that's the only way to verify if the words can make it up. So we can start just by iterating through L and seeing if this substring matches any of the words here. And if it doesn't, we just extend the substring to the next letter. And now we check if this is in the word dict. And if it's not, we extend it again. And if not, we extend it again. And then at this point, we see that the word leet matches. So what we want to do is now we want to start looking from here and seeing if any of those words match. And then if we manage to get to the end, then we return true. Otherwise, we return false. The problem with this solution, though, is that maybe we could find a string that matches just the leet part, and then nothing else would work after that. So we would need to go through every single combination possible. So we would need 3 for loops there, which would be n cubed time. Not only that, but we actually need to iterate through every single word in the dictionary as well, which we can say is just size m. And additionally, to compare strings, it takes n time. So the final time complexity for this brute force solution would be O of n to the 4th times m. And if you show this to your interviewer, they're probably just going to laugh at you and walk out of the room. So let's try and improve it. I added this extra word here in the dictionary just to be able to explain the following examples better. So a way to get rid of one of the n's is by, instead of blindly iterating through the substrings and seeing if they match, we can just instead iterate through word dict and just check if, for example, let's say we're starting here, check if this substring here matches. And if it does, then we can move our pointer here and check again. But like I said, this still takes 2 pointers, so it only gets rid of one of the n's. And just to clarify, the reason we need 2 pointers still is because, let's say we do find Lee first. Well, there's no word in the dictionary that has T code in it, so we're going to find that, and then we're going to have to return our pointer back to the original point, and then we're going to find leet, and then we're going to find code. So now that we figured that out, we can get rid of one of these n's, so now our runtime is going to be n cubed times m. Which is still terrible, but at least we're making progress now. So what other ways can we get rid of another n? For these kind of problems, there's normally a lot of repeated work, and if you know by now, repeated work probably means that you should use a dynamic programming approach. So let me show you what I mean. Here I've added 2 extra words to our dictionary, L and EE, and I'm going to show you why we should use dynamic programming. So I'm going to get rid of these 2 words because they're not really necessary for now, and our algorithm currently is to have our word and use our words from the dictionary to see the first 3 strings. So we would have Lee, EE, and L. And from Lee, we see we have a match. So we're going to be left with T code. And then for EE, there's no match. And then for L, there is a match because that is the first letter there. And we're going to be left with EAT code. And now we can keep going. So we see that if we branch out from here and try Lee again, EE and L, they're all going to return no match because obviously they don't match. And now if we go to our EAT code here, these 2 don't have a match, but EE does. And now we're going to be left with T code. And as you can see, we already calculated this over here. So what we should do is store that value in an array, and that way we don't have to use repeated calculations, and that would get rid of another n. So what we've done so far is, instead of randomly making substrings here and then checking the word dict, we're instead going from the word dict directly to the string and seeing if they match. So for example, for Lee here, we would take the first 3 of our string and see if they match. And if they do, then we continue looking for more matches after that. And that got rid of one of the n's. Additionally, we saw that there's a bunch of repeated work here, not particularly for this example, but if you go to other examples, it'll come up. And to get rid of an n, we just use dynamic programming. So that way, if we ever go to this exact string here, we know there's no matches in our word dict. So now we have a time of O of n squared times m, which is an acceptable solution depending on how you implement it, because there's not really much else you can do here. So now I'm going to show you how this dynamic programming solution can look. So what we want to do is iterate through every word in word dictionary and iterate through every single character in the string. So to start, we want to initialize our I to 0 so we can start at the L here. And also here, we're just going to call this word for now. And what we want to do is check if this word starting from I equals 0 is in the string. So let's see. This word is a length of 3, so we want to check the first 3 characters of this. And we can see that it does match. So now we know that starting from T would be a valid position because we found a match for this part and we no longer need to consider it. So now we can check this next word, which is leet. And let's see, starting from I equals 0 to the length of this word, which will be 4. So we consider these first 4 characters. Do these match? Yes. So now we know in the future that starting from here would be a valid position. So for example, if we had a word T code in our word dictionary, or if we had the word code in our dictionary, we could return true at the end. And now we go to the last word in our dictionary, which is code, and it is a length of 4. So we're going to check the first 4 characters starting from I equals 0, and we're going to check if leet is equal to code, and obviously it's not. So now we can just go to the next iteration where I is equal to 1. So at this iteration, we see that we don't have a valid starting position. The reason is because we don't have an L in our dictionary. If we did, and we started again at I equals 0, we would see that this and this match, so we would have marked this as a valid starting position. But since we don't, then we can't start here. So now we would try and do I equals 2. And as you can see, this is also not a valid starting position, so we can just go on to 3. Is 3 a valid starting position? Yes, because we marked it. And we can see in the dictionary that there's no T code in there, so we can just skip over it for now. And we just go to 4. At 4 is also a starting valid position, and we can see that the word code is in the word dictionary. So in the end, what we would do is mark this as a starting valid position. And as you can see, this is going to be outside of the string. So if we ever get to this point, we know we reached the end of the string and we found enough matches in our string using our word dictionary. So how does this look with the actual dynamic programming array? So this is what our array is going to look like. As you can see, I've moved this empty space here into the beginning because I'm going to be iterating going forwards. You can leave it back here for iterating backwards, but just make sure to account for that. Before I show you how it works, I'm going to write some pseudocode out so you can see how we're going to iterate. So we're going to iterate through the word dictionary and through the string. So we're going to have a double for loop. So what do we want to do inside this double loop? Well, let's see. Let's start from I equals 0 here. I'm pointing to the L there, messed that up. And let's point to this first word because we're doing it for every word. So let's see. This word is a length of 3. So we're going to check the first 3 characters and see if they match. And they do. So what do we want to happen? Well, since we're doing dynamic programming, we probably want to use our previous result somehow. But this is our first iteration where we actually found a result. And that's what our base case is for. So we want to set result at I plus the length of the word equal to result at I. And currently you see our I is 0. So if you go to I equals 0, we get true. And then the length of this word is 3. So I plus 3 would be 3. So we're going to set this equal to true. And you can see that from our example, I said that we're going to mark this as our valid starting position, but instead it falls under this E here. The reason for that is because this is shifted over by 1 to the right. So now when we actually access results of 3, we see that here for I equals 3, it is a valid starting position. So that's how it's going to be used. So now we want to check our next word, which is going to be leet. And leet is length 4, and let's see, the first 4 characters of this starting at I equals 0 are equal to leet, so we're going to set I equals 4 to true. And now we go on to the last word, code. We know that's not the first 4, so we're not even going to entertain that. And now we just go over to I equals 1. So if you go to I equals 1 here, we see that there's no value here, so we can just assume it's false. And because it's false, we know it's not a valid starting position, so we can just go on to the next one, 2, and that's also not a valid starting position, so we can just mark that as false as well. So as you can see here, we only want to do this if a condition is met, where if result at I is true, then we want to do this. So let me edit the pseudocode so it looks a little neater. So now the if statement is, if our result at our current iteration is true and the word is equal to the string, then we want to set the result at I plus the length of the word we looked up equal to true. And the reason we just set it equal to true is because result at I is already going to be true, so I feel like it's a little redundant to set it to that. Might as well just do it directly. So now let's continue. So we go to I equals 3, so now we're starting from this point. And as we can see, I equals 3 has a true, meaning that this gives us a valid starting position. So if we look here at the third index of this string, we could start at T and see if TC or Tcode is in our word dictionary, and if they were, then we would update the array accordingly. But as you can see, we don't have any matches, so I'm just going to go to I equals 4. So now we check our index 4 at our array, and we see that is true. So we could start searching for a word that fits the rest of this string, and as you can see, we have code here. So what we want to do is update our result array at I plus length of W, which would be 4 plus 4, since the length of code is 4, and then set that equal to true. So what we're going to do is set index 8 to true. And then now we can just quickly iterate through the rest of it so I can show you what's going to happen. So for I equals 5, it's not valid because there's nothing here. We can just say it's false. Same thing for I equals 6 and 7. These are both going to be false because we didn't find any matches for those indexes. And then at the end, we can just return our result array at the last index. And that's basically it as far as this code goes. So I'm just going to clean it up one more time and then we can talk about the complexities. So the time complexity for this algorithm is going to be O of n squared times m. And m is for iterating through every word in dictionary, and one of the n's is by iterating through the whole string, and the last n is from comparing the strings. And our space complexity would be O of n. But actually there's a different solution that doesn't require much changing, and it actually makes the time algorithm O of n, but the space would be O of n plus m. And what the solution is to put this whole array into a hash set, so that way whenever you look up a word, you can look it up as a key in the hash set, and then that only takes constant time. And I'll just do that in the code. So let's get into it. So I'm going to start by having a variable to keep track of our string length. So I'm going to call it length of string and set it equal to the length of the string. And then from here, we want to initialize our set. So the way it works on Python is all you do is do set and then word dict. So now we can just look up the word in constant time without having to iterate through every single character. And then now we want to initialize our array where we're going to store our values. So I want it to be 0 for a length of string plus 1. And the reason I want to do plus 1 is because we want to set a space for the base case. And then now we initialize our base case to be true. And actually this is supposed to be false, not 0. And then now we want to iterate through the string. So I'm going to do for I in range of length of string plus 1. And same reason here, we're doing that because we want to iterate through the array. And then now we want to iterate for every word in word set. And then now we just do our if statement. So our if statement is pretty long, so I'm going to try and go through it slowly. So there's 3 things we want to check here. First, we want to check if the words, or if the word equals the substring. Additionally, we don't want to get any out of bounds errors, so we want to check that I plus the length of the word is not greater than the length of the string, because then that would just give us an out of bound error. And also we want to check if result of I is equal to true, because that would tell us that this is a valid starting position. So the way it's going to look is if result at I equals true, and you don't actually need this part, so I'm just gonna delete it to save some space, and I plus the length of the word is greater than or equal to, or actually less than or equal to, the length of S, and if our substring, which starts at I and ends at I plus the length of the word, is equal to the word. But this will compare the strings, and we don't want that. So what we want to do is check if it's in the actual set. And then from here, what we want to do is, well, actually this is not supposed to be in there. It's supposed to be out here. Okay. And then now all we want to do is set results at I plus length of the word equal to true. And that's basically our whole code. After that, we can just return result array at the end, and we can just do -1 for that in Python, and the code should work. And as you can see, the code is pretty efficient. So now I'll go through the code manually. To start, I've used the same example we've been using so far, just the Leetcode one, because I feel like it's the simplest to understand. And I've also initialized the word dict to be the same. And now let's start. So in the code, we initialized our length S to be the length of string. So this is just going to be equal to 8, and we can just keep track of it here, so it's not going to change. And I've also initialized the word set down here, and this is supposed to be a hash set, and the reason we used it is because to look up a key in this, it takes O of 1 time, compared to if you're comparing a string to another string, that takes O of n time. Next, we're going to initialize our dynamic programming array. So I just called it result, and it's set to false for a length of string plus 1. And as you can see here, this is length 9, and they're not all initialized to false because I'm gonna write in them and I don't want to make it look messy, but we can just assume these other ones that are blank are false. And then our base case is true here, as you can see, and then now we want to iterate through the length of string plus 1. So our I is going to start at 0, and I've already done that here. Now we want to look at every key in the word set, but I just called it word here. So for every word in word set, what we want to do is check if this condition is true. So we know that for I equals 0, result at I is going to be true, so that's checked off. And then we know that I plus the length of the word, both of these are 4, so we don't have to worry about that, so that's checked off as well. And now let's see. Our string at position 0 all the way through I plus the length of word, which is going to be 4 in this case, we want to check if that is in our hash set. So let's see. The first word is going to be leet, and that is the first 4 characters here, so that will be true. And what we want to do at that point is update result at I plus the length of word, which would be 0 plus 4, so we want to update index 4 to be true. So let me do that here. And we could also look at code, but that won't change because it won't match. So I'm just going to go to the next iteration. So let's go to I equals 1. And at this point, we see that result at I is not true because it's empty. So I'm just going to say it's false here. And then we go to I equals 2 because that condition is never going to change. So for I equals 2, same thing. It'll be false because result at I is initialized to false here. And when we first looked through leet and code, we didn't find anything that ended at the second index here. And so now we go to I equals 3. Same thing for I equals 3. So we're just gonna say it's false again. And now for I equals 4, it is true again. So let me just do that. And now we see that I plus the length of the word. So let's see, 4 plus 4, that is equal to the length of the string. So we're still okay here. And then now we want to check our substring. So starting from the C, let's see if any of these match. Well, we can see already that code matches, so I'm not going to go individually line by line, and we can just see that it matches here. So what we want to do is set result at I plus the length of word equal to true. So I is currently 4, and the length of the word is 4. So for index 8, we want to set that equal to true. And then now we would iterate through 5, 6, and 7, but you already know that these are initially set to false, so we're not even going to go to this if statement ever. And now at the end, we want to return the last index, which is true. And we know because we went over the example like 20 times, so this is correct. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.